In this problem, we look at an application that involves a demand equation. The price P in dollars and the quantity X sold of a certain product obey the demand equation P equals negative 1/10 X plus 1,000. We'd like to find a model that expresses the revenue R as a function of X. Recall that the revenue is given by the product of the quantity and the price per unit, that is R equals X times P. Since we want R to be a function of X only, we need to express P in terms of X. Now it's given to us here as our demand equation, so we can write R of X is equal to X times, and we'll use our expression here for P, negative 1/10 X plus 1,000. And so our revenue function R of X is negative 1/10 X squared plus 1,000 X. Next, we'd like to determine the revenue if 400 units are sold. We're going to let X equal 400, which means we evaluate R of 400. We'll have negative 1/10 times 400 squared plus 1,000 times 400. This will give us negative 16,000 plus 400,000, which gives us a revenue of $384,000. In part C, we'd like to find the quantity X that maximizes the revenue and then determine what that maximum revenue is. Recall that our revenue function is negative 1/10 X squared plus 1,000 X. This is a quadratic function. The leading coefficient is negative, so the graph is open down, which verifies that we do actually have a maximum. The quantity that maximizes revenue and the maximum revenue we can find by locating the vertex of the graph of this function. The X coordinate is given by negative B over 2A. We can identify that A is negative 1/10 and B is 1,000. We'll have negative 1,000 divided by 2 times negative 1/10, which gives us an X value of 5,000. So the quantity X equal to 5,000 will maximize the revenue. To determine the actual maximum revenue, we evaluate our function at 5,000. That is, we find R of 5,000. It would be negative 1/10 times 5,000 squared plus 1,000 times 5,000. So we'll have negative 2,500,000 plus 5 million, which gives us a maximum revenue of 2,500,000. So 5,000 units maximizes revenue, and the maximum revenue is $2.5 million. In part D, we want to find the price that the company should charge to maximize revenue. Remember, our demand equation was P equal to negative 1/10 X plus 1,000. We know the value of X that maximizes revenue. We found that to be X equal to 5,000. So we simply need to evaluate P for X equal to 5,000. We'll get P equals negative 1/10 times 5,000 plus 1,000, which gives us negative 500 plus 1,000, or $500. So the company should charge $500 per unit to maximize their revenue.